All right, so we've been talking about derivatives the entire class. That's the main focus of calculus 1. Learning what well, first we learn limits in order to define the derivative. Then we learn how to take the derivative and what it means. Then we learn applications and various uses of the derivative. That's what we've done so far. Since the beginning of the semester until right now. All of it was involved or used for the derivative. Final chapter, chapter 5, the final exam, is about antiderivatives, also called integrals or integration, which is going to be what calculus 2 is about. So cal 2 is going to be focused on integration, just like cal 1 was focused on derivatives. Integration is basically the opposite, called the antiderivative, same thing. Although after chapter 5, they don't really use the word antiderivative anymore. But when they first introduced so this is just the formal definition here. So a function capital F is the antiderivative of lowercase f on some interval I, doesn't matter, where the derivative of capital F is equal to lowercase. So the antiderivative of this guy is this. So you go backwards. This is math symbols for all x in the interval y. Upside down a, x, epsilon, I. Theorem 3.1. So if f is an antiderivative of f on I, then capital G is an antiderivative of lowercase f on I. If and only if G is of the form capital F plus C, and this is true for all x in this interval. For C some constant, just whatever number, G is called the general solution. Okay, so if you find the antiderivative of lowercase f, it's going to look like this, right? As we said, that's how we define capital F up here. But you're going to have to add a constant. So anytime you do integration, you add a C. That's what this is saying right here. The antiderivative constant right here should be lowercase f. It look the same to me, so we fix it. So the antiderivative of lowercase f is equal to capital F plus some constant. We call this piece right here the integrand. That's a piece that we're integrating or finding the antiderivative of. Dx is also, this kind of tells you what you're integrating with respect to. So it's going to be with respect to x dx. It also is a symbol for the change in x or the infinitesimal thickness of a rectangle, which we're not going to talk about that the way they define the integral. I'm just going to show you how to find it. C is the constant, some real number, right? Here's some rules, and this is basically showing you how they are in fact inverses of each other. So if you integrate or find the antiderivative of something that has a derivative, you cancel the derivative. You take the derivative of an integral, cancel the integral. Okay. Okay. Any questions on those general ideas? I'm hoping you saw the video, but I just summarized the most of it here. Okay, let me give you a bunch of formulas. I think I sent you the formulas for calculus, right? All the limits and all that stuff. Do you remember? Do you still have that? Just in case you don't, I'm gonna throw it. All right, so those are only derivative, antiderivative and derivative. I'm gonna open it up and share the screen. So I gave this to you a while back. Here's all the derivatives, chain rules, all that stuff. So what you're gonna need is the antiderivative. So you're gonna go backwards, okay? So picture, find the integral of this guy, means I'm gonna go back to here. Find the integral of this takes me back to here. Integral of secant squared, tangent, etc. All right. I'm gonna go ahead and write them down for you just so you have the formats. Right. I wrote them here. Here are the basic integration rules. Number one, the integral of 0 with respect to x is gathered to some constant. 2, the integral of a constant times dx is equal to kx plus c, where k is an element of 3. The integral of k times a function, just factor out the constant outside and just do the integral. Integral of f of x plus or minus g of x dx is equal to integral of f of x plus or minus the integral of g. So you can separate them and then do the integral separate. Okay. Whether it's plus or minus. The integral, and we'll find the main one that is the integral of the power function. So all you do is add 1 to that whatever power you have, then divide by that same result. 6, integral of cosine dx is equal to sine x plus c. 7, integral of sine dx is equal to negative sine plus c. The integral secant squared x dx is equal to tangent x plus c. Integral of secant x tangent x is equal to secant x c. 10. Integral of cosecant squared x dx is equal to negative cotangent c. Integral of cosecant x dx is equal to, should be cosecant. Integral of cosecant cotangent dx is equal to negative secant c. Integral of a to the x dx is equal to 1 divided by ln a times a to the x plus c. integral EX dx is going to be 2 self plus some constant. So whenever you integrate e to the x, so this is 1 plus 1 integral of x dx for x to the negative 1 ln. Those are all the integration rules we're going to need. Start doing some examples. Is there any questions on rules, definitions? Oh, let's do some examples, huh? Example 1. Find the antiderivative of f of x equal to 2x cubed. So basically integrate 2x cubed dx. So remember the rule of 3. 3 says you can pull out the 3 outside or the 2 outside and focus on the inside. Factor out constants outside the interruption. After that, use the power rule. So the power rule says you add 1 and then you add your c. So once you integrate, you apply the rule, that's when you use plus c. So that'll be 2x to the 4th plus c, which reduces to x 4 2. So we apply rule. It's 5. And that's it. This is the antiderivative after you integrate that function f. And if you take the derivative of this, you're going to end up back at the beginning. So this is like capital. Okay. Another one. Same question. Find the answer. X equal to 2x. So the integral of 2x, oops, it's the same, sorry. I wrote this down. So will be squared remember how rule number 6 forces you to separate intervals. So separate the interval second. Okay. Oh, expression. Two plus the constant of x, and always add your c. No more integrals, so the answer is x cubed 3 plus 3x. Any questions on? That's bad, right? Now in the homework, when they ask for find general solution of dy dx equal to 3x to the 2 7. Well, basically, they want you to find y function of y. So all you got to do is integrate both sides to integrate x to the 2 7. So these cancel, leaving you with just the y function equal to 3x to the 2 7 plus 1. 2 7 plus 1. That'll be x, 3x to the 9 7 or 9 7. Okay, so that'll be 3 over 1 times 7 over 9 x to the 7. So y is equal to 7/3 x to the 7. Okay. So this thing is very similar to what we did before. It's just that general solution means you're looking for y function. So the 4th root of x dx. So that'll be equal to the integral of x to the 1/4 dx. So you got to change it to a power so you can apply the power rule. So remember, the nth root of x is equal to x to the 1 over n. So just in case you forgot, it's right there. The fourth root becomes a 1/4 power. So now do your power rule. 1/4 plus 1 over 1/4 plus 1. Add your c. Let's add my c over here. So that'll be x to the 1/4 plus 1 is 5/4 over 5/4 plus c. So that becomes 4/5 x to the 5/4. So that would be your antiderivative. So if you see square roots in the, or any kind of roots in your homework, just change it to a power. And then you just do the same thing you did before. All right. So far, any questions? Let me know if you need to slow down. It doesn't make sense. Just tell me. Now, just remember, it doesn't always have to be x. This is a theta squared plus secant squared theta d theta. So I'm integrating with respect to theta. So treat it the same way you would before. Separate. It'll be 3 over, sorry, 2 plus 1 over 2 plus 1 plus antiderivative of secant squared is tangent, okay? Based on the formulas that I wrote. So our answer will be theta cubed over 3 plus tangent theta plus c. Any questions on number 5? All right, so let's do one last one for this section here. Integral of 3 sine x minus 7e to the x dx. So first step is create separate integrals and then pull out the numbers. Then integrate. Integral of sine is negative cosine. Integral of e to the x is always itself. So negative 7 times ex. Then you add your c. So this becomes negative 3 cosine minus 7 ex plus c. So let's open up the homework so you can see it. 5.1. It's just solving those habit questions. So make sure you have the formula notes. See, time, general solution. Different pieces, just integrate each piece separately and receive. Let's go ahead. It's the same thing. The only thing that we didn't do is this particular solution. So this is not right now. Particular. Solution. Differential equation, all that with an equation with roots inside of it. So the derivative they gave us, the differential equation, is 4x. They gave us an initial condition. So that the original function at 0 is equal to 7. So if I integrate f prime respect to x, integrate 4x dx, that'll get me to 4x squared over 2. That's a constant, right? Once you have that, you need to solve for c to find this particular solution. So in a real world, these different equations represent forces on an object, accelerations, friction, etc. But you'll have this constant here, so it'll depend on the initial condition. So maybe like initial temperature, initial position, initial speed, velocity. Then you can find the specific solution. So all I got to do, f of x is equal to 2x squared c. Remember that f of 0 is equal to 7, so moving 0, right, it's 7. So 2 times 0 plus c, 7. C is 7. So the actual particular 2x squared is 7. Any questions on particular solutions? Okay. All right. Let's see. Two. It's not too bad. Okay, I guess we can stop here. Finish chapter 5 next week. Show you.